Simplify each multiple variable function. We have a function defined with variables x and y as 7 minus x squared minus 7y squared. In our first evaluation, we are asked to substitute in 0 for both x and y. 7 minus 0 squared minus 7 times 0 squared. This all dissolves down to 7. In the next example, we're asked to replace x with 0, y with 1. 7 minus 0 squared minus 7 times 1 squared. Put this in your calculator as needed. 1 times 1 is 1, times negative 7 is negative 7. So that's 7 minus 0 minus 7 totals 0. In the third example, we are asked to replace x with 3 and y with 2. 7 minus 3 squared minus 7 times 2 squared. This works out to negative 30. 7 minus 9 minus 28. The fourth evaluation, we're asked to replace x with 3, but leave y alone. 7 minus 3 squared minus 7 times y squared. No number for y, just leave it as it is. 7 minus 9, that's negative 2, minus 7y squared. In some multiple variable functions, it's important to leave one variable fixed, and you can let the other variable or variables fluctuate. In our last example, we're going to leave x alone, and we're going to replace y with 0. 7 minus x squared minus 7 times 0 squared. That term goes away, leaving us 7 minus x squared. Continuing, we have a 3-variable function defined as f of x, y, z, and it's defined as the square root of y plus z divided by x. These numbers in parentheses are in order, respectively, with x, y, z. So f of 136 is going to be 3 plus 6 divided by 1. Square root of 9 is 3, divided by 1 is 3. The second evaluation, we're going to replace x with 9, y with 9, and z with negative 4. 9 plus negative 4 is 5. Square root of 5 is irrational, so we will leave it square root of 5. X is our denominator, so that remains 9. Compound interest is a formula that you've seen multiple times, and it has several variables involved. Capital P is principal, R is interest rate in decimal form, and T is the time in years that an account is active. E, that tells us that it's compounded continuously. For this problem, our first evaluation, we're going to replace P with 300, R with 0.11, and T with 3. Plugging this into your calculator, remember you can access E by hitting second and your natural log or ln button. Carefully typing this in, make sure both of these numbers count as the power of E. You can also put these two numbers together and just call it 0.33. Typing this in, we get 417.29. Next, we're going to change the numbers up a little bit. Same function. P will be 1700, R is 0.13, T is 21. That comes out to a really large number, a little more than 26,000 to be exact. Actually, to approximate, because you get a never-ending decimal, but we usually round them off when it's a money problem to the nearest cent. A manufacturer estimates that its production can be modeled by the following 2-variable function. F of xy is equal to 100 times x to the 0.75 power times y to the 0.25 power. Estimate the production level when x is 1700 and y is 1000. This should say the, it's just a typo that I missed. 100 times 1700 to the 0.75 power times 1,000. Remember, these are your x's and y's to the 0.25 power. Carefully put this in your calculator. It's all multiplication. Be careful that after you plug in your power of 0.75, that you close parentheses before you go to 1,000 to the 0.25 power. Long story short, when it's all said and done, you get a number that's 148,880.11.